Now, the basic classification model and the basic regression model. We have discussed the basic classification model and the basic regression model, the MLR, multiple linear regression, and the binary logistic. When these basic models or baseline models does not give us the results which we expect, or they fail due to outliers and other, the next set of algorithms which we use are tree-based algorithms. So within machine learning, within the supervised tree-based models, single tree model. Within the single tree model, the algorithm is decision is a single tree model that is part of the tree-based models. Now, if you are looking at the tree-based models, they look like this. A typical decision tree will have root node, terminal nodes, or leaves. A typical decision tree will look like this. So there will be a root node. The beginning node is we call it as root node. Then the decision nodes. The decision nodes is the nodes on which the tree will split. And then you have the terminal nodes or the leaf nodes. A tree will have a lot of subtrees and branches within the subtrees. So it is a very large. So decision tree is a binary splitting. Decision tree, a binary on a logical and further in either leaf or terminal nodes or split into decision tree is a binary splitting tree. It's a binary splitting tree. That means it will always split into two. Left side is yes, right side is no. There will be a logical test in between. Take for example, greater than equal to 4.2. Yes or no. Male, yes or no. Male, yes or no means if it is male, yes, male. If it is male, no means it will be female. So based on a logical test, it will split into two. Binary splitting trees. We'll go into further decision nodes, or it can end into a terminal node or leaf node. Now, once all observations into terminal nodes, the tree growth will stop. The tree will stop once all the observations are classified into the terminal node or leaf. Once the tree is classified into a particular, once the observations are classified into different terminal nodes and leaves, the tree growth will. So decision tree is a binary splitting tree with root node at top, followed by decision nodes and leaf nodes and terminal nodes. Splitting happens based on a logical test. Left side is yes, right side is no. Right. And once all the observations are classified into the terminal nodes or leaves, the tree growth will, in the back end, it will build a very, very large tree. In the back end, it will build a very large tree, but then it cuts the tree and it will finally gives us a tree which is relevant to make predictions and decisions. Decision tree also uses recursive partitioning. Recursive partitioning is another thing which is the tree splits on node number of observations, previous decision node number of observations, and as the tree, the number of observations. So recursive partitioning is another thing which is adopted by decision trees. The root node has 5,000 observations. It's split into 3,000, 2,000. This 3,000 will further split into say 1,200, 1,800. This 2,000 will split into 1,000 and 1,000. Now that 1,000 will split into 200, 800. Like that, each time the tree splits, it will split on the previous node number of observations. So as the tree grows down, the number of observations will also decrease. Per node number of observations will decrease. This process we call it as recursive partitioning. Recursive partitioning trees. The tree splits on the previous node number of observations, and as the tree grows down, the number of observations per node will reduce. Decision tree is a non-parametric algorithm. When I say non-parametric algorithm, it means no prior assumptions. Whereas multiple linear regression and binary logistic regression are parametric algorithms. Parametric algorithms will have assumptions. And unless you meet those assumptions, their models will fail. Whereas non-parametric algorithms will not have any prior assumption. They work well and skewness in data. So decision tree works well with skewness and outliers in. So they are very, very powerful, which don't have any prior assumptions. It's a non-parametric algorithm. It works with any type of data. Preferably, the data size should be larger. It prefers larger data size. and the computational process is also very, very fast. The computational process is also very, very fast. In decision tree, the most important thing is the tree splitting methods. How the tree will split. The tree splitting methods are very important. The one which is mostly used and the default in all the softwares is 1 minus probability, 1 minus sigma probability of I square. Gini is, decision tree uses probability. Classification, decision tree, probability, lowest Gini, first split. So what the algorithm will do is, it will calculate Gini of all the variables with the dependent variable. It will calculate the Gini of all independent variables with the dependent variable and identifies the lowest Gini. Lowest Gini is the first split and ascending order till 0.40. Gini greater than 0.40, the variable will be dropped from the tree. The variable will be dropped from the, so as process, Gini of all variables will be calculated with the dependent variable, and then the lowest Gini will be identified, and that lowest Gini variable will be the first split and ascending order, next lowest till 0.40. If the Gini is above 0.40, the variable will be dropped from the tree. It is considered as insignificant variable. The second method is entropy and information gain method is equal to sigma minus probability into log probability of I, log second base of probability of minus probability of I into log second base of probability of I. Information gain is equal to entropy of dependent variable minus entropy of information gain is entropy of dependent variable minus entropy of variable. Highest information gain and descending order till 0.50. Information gain less than 0.50, variable is dropped from. There are many splitting methods. Chi-square based method is there, Bayesian methods are there. But the ones which are used in machine learning, Gini, which is the default method in Python, R, SAS, any software, Gini is the default method because it is easy to calculate. The second method is entropy and information gain. Within machine learning, within tree-based models, be it single tree model or multi-tree model, the two methods of splitting that are used are Gini method and information gain method. Gini method and information gain method are the tree splitting methods which are used in. There are other splitting methods also, but these are the two methods which are used. Default is Gini because it is easy to calculate. You can also change the option to information gain based on your requirement, but you will not see any major difference. Only marginal differences will be there in the. So decision tree, when used for regression, it uses the ID3 algorithm, standard deviation reduction. Standard deviation reduction is used. If decision tree is used for regression, decision tree is a model. From now onwards, whichever model I talk about, they work for both as regression model as well as classification model. Standard deviation reduction. So I'll show you the calculation. That time we'll explain it, but the method is this, which is based on, again, this calculation is purely based on standard deviation. So decision tree is both used for classification. It is also used for decision tree is also used for missing value imputation. In some of the missing value imputation algorithms, decision tree method is also used. Decision tree is also used as missing value imputation algorithm. If you are using mice algorithm, you can give method is equal to tree. That means it uses decision tree to impute the missing values. Decision tree as part of output variable importance. This algorithm is also used as a feature variable selection method. Now, if you have hundreds of variables, you need to reduce the variables. If you are trying to build a model with 100, 200 variables, your models will not perform well. There are algorithms for doing that. One algorithm is dimensionality reduction, is principal component analysis. If you don't want to use that, you want to choose variables which are important, you can do manually. Based on your domain knowledge and subject knowledge, you can do it manually. If you are not able to do it manually, you can run the decision tree algorithm. As part of the output, it will give you variable importance based on the Gini, and then you can choose those important variables and rebuild your model. Feature selection or variable selection is one of the critical process in machine learning and data science. In real-time data science, you will get hundreds of variables in your data, but we cannot build models with hundreds of variables because that will take time, it will take computational power, and the accuracy levels will also be. That means we have to reduce the number of variables. Either we can do it by using manual selection. Manually, if your domain expertise is there, you can do it using manual selection methods, or you have these algorithm-based selection methods like decision tree. As part of its output, decision tree by default will give you variable important, either based on the Gini or the information gain, or it gives you based on the number of times the variable appears in the different branches of the, because like I told you, the threshold, Gini 0.40, it automatically eliminates some variables. So Gini is there, less than 0.40, or sorry, greater than 0.40. Decision tree is a very, very important feature selection method or variable selection method that has one of the best accuracies in industry. A lot of people use decision tree to do variable selection and feature selection when they have a lot of variables. And when you rebuild that model, a simple model like a linear regression or a logistic regression, if you build after the variable selection done by decision tree, it has a better performance than the. So we have seen decision tree has a lot of utility in data science. It is used in missing value treatments. It works with any type of data. It works with missing values. It works with skewness. It works with outliers. And it also plays a role in feature selection and variable selection. It's a very, very interesting. It works with large scale data. It needs less computing power. The only disadvantage of decision tree is overfitting. What is overfitting? Greater than 0.95 and close to, and accuracy also greater than 0.95 and close to. This is the only disadvantage. By default, because it builds a very large scale decision tree in the back end, it typically tends to overfit. R square greater than 0.95 closer to 1, accuracy greater than 0.95 closer to 1 or equal to 1. Sometimes you'll get 100%. This is the only disadvantage. It tends to overfit. Now, the other way of defining overfitting is also validated cross-validation or repeated testing, repeated running of the model with same data. Overfitting can also be checked using cross-validation. Cross-validation is repeated testing. I ran the model first time. I got accuracy of 0. I ran the model again. Now I got an accuracy of 0.70. That means there is a drastic reduction in accuracy. I ran the model again third time. Again, the accuracy fell down to 0.68. I ran the model again fourth time. The accuracy went up to 0.85. So these up and down movements in accuracy, we call it as overfitting. A smooth line, if it is there, it's a proper model. If you have lots of up and downs in your accuracy or R squares, that means the model is overfitting. In the trained model, you got 0.90. On testing, you got it down to 0.68. That's a huge difference, right? So that problem, we call it as overfitting problem. So this overfitting problem is the biggest problem and the only problem that decision tree has. Now there is a method to control. Overfitting in decision tree is controlled by choosing depth of the tree. How many levels you want you want 4 depth tree. That means it will build a tree of only 4 levels. If you say 10 level, max depth is 10, it will build only with 10 levels. By controlling the max depth, we can control the reducing the max depth will control the overfitting. By default, in all the softwares, max depth is 32. By default, in most of the softwares, I think in Python, they removed that 32. Now it is none. Max depth is none in Python. That means it can take any value. Whereas in R, it is still max depth is 32. It goes up to 32 levels, and very rarely we see trees that go beyond 32 levels. If the tree is growing beyond 32 levels, that means you have too many variables. You have to reduce the number of that itself is an indication that you have too many variables, you have to reduce them. So I think now Python does not have the max depth restriction. Previous versions used to have a 32 as the depth fixed by the researchers based on the experience. Now there is no max depth. So this overfitting can be controlled using the max depth of the tree. So you can control overfitting. So it is both a classification and a regression model. It is a both classification in what you call classification model. Okay. Now another thing you need to understand decision tree is in regression, the output is what? Equation. In multiple linear regression and binary logistic regression, the output is what? Equation. You will get an equation, right? The output is a equation because it solves for coefficients and the intercept and you create an equation. Now, the output is a decision tree. The output is a decision tree. Tree plot is the output. Tree is read. You always read the tree from top to down. Now, rules are created from tree and rules are created and these rules are used for prediction. Rule-based prediction system. Equation-based prediction system in multiple linear regression and binary logistic regression. Here it is rules. Now, what are these rules? From the decision tree, you can create rules. Now, look at this is a decision tree. The rule is if petal length less than equal to 2.45. If petal length, this is IRIS data, one of the textbook data says, you know, if petal length is less than 2.45, if it is true, then it ends there as a terminal node. The class is setosa. If petal length is not less than 2.45, then the next is petal width is less than 1.75. So this rule goes this way. So if petal length is not less than equal to 2.45 and petal width is not equal to 1.75 and petal length is not equal to 4.85, then the class is Virginica. So if you look at this tree here, the rule will be like this. If petal length not 2.45 and petal width not less than 1.75, not less than 4.85, the class is Virginica, right? Then the class is Virginica. This is the rule. This is the rule which is created from the tree. So one side of the rule, you can see here, right? I am going this way, top down. This is the rule it creates. And how it predicts Virginica? Based on this rule. If these conditions are met, then the class will be assigned. So these rules are created and rules are used for prediction. Outrightly, see if it is greater than 2.45. If it is less than 2.4245, it is outrightly setosa. The one with petal length less than 2.45 is setosa. Versicolor is terminal node versicolor is this. So all these truths. If petal length is not less than 2.4 and then from here all it is true. This is all true, right? Greater than, then you get the versicolor. Why I have done is this one. There are arguments which you can give in decision tree classifier. You can see by default is and max depth is see Gini, entropy and log loss. The other new one which they have added is log loss. Earlier it was only Gini and entropy. Now they have added the log loss, which is also a type of information gain only. So you can see a lot of documentation is there in this thing. You can look at that. Within classification, decision tree and multi, it works both as a binary classification model as well as a multinomial classification model. So decision tree, if you are looking at the tree-based models, if you want to understand what trees look like, the theory is also given here. The formulas, theory, everything is there in the documentation. And the tree is very easy to interpret. Based on the tree diagram, you can easily interpret. Only thing is overfitting, and sometimes it will build very large trees. Complex decision trees will be built. Very large trees with too many nodes that you have to control using max depth. Because if you have too many nodes, you can't write a rule very easily, right? So that also, for software also, it will create problem. So it is better always to have a control on the depth. Depth of the tree has to be controlled. That way you will have a tree which works well and also performs well on the data. Now, let us understand the methodology using Excel. I have sent you an Excel sheet. Just download it. All right, all of you open the Excel sheet. Now here we have 4 independent variables A, B, C, D, and the dependent variable is variable E. Variable E has 2 classes, positive and variable E has 2 classes, positive and negative. Okay, now A, B, C, D are the independent. Okay, this is the binary classification problem. This is a binary classification problem. Now, let us start with the first calculation of Gini for variable A. I am starting with the calculation of Gini for variable A. Now, the dependent variable has 2 classes, positive, right? The dependent variable has 2 classes, positive and negative. These are the values for variable. Now, what the algorithm will do is, I told you this is numerical continuous data. This is numerical continuous data. Now it has to be converted into a binary class, binary split or a binary class data. So what the algorithm will do is it will randomly pick a value. It will randomly pick a value and then uses this value as a binary. Let us say it randomly picked 5.2, greater than equal to 5.2, less than 5.2. It randomly picks a value within the range. Okay. Let us say it has picked a value of 5.2. Greater than, now it has split, we got a logical test. What is the logical test? Greater than equal to 5.2, yes or less than 5.2, yes or no. How many within the positive, how many are greater than equal to 5.2? Within positive class, there are 3 greater than equal to 5.2. Within negative, how many are there? 1, 2, 3, 4, 5, 6, 7. Less than 5.2 within the positive category 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5, and only 1 in negative. All right. So it will create a table like this. It will create a table like this. Now we will calculate 3, 7 is equal to open 2 brackets 3 divided by 10 close bracket to the power of 2 plus open bracket 7 divided by 10 to the power of 2 close is equal to 1 minus open bracket 3 by 10 whole square plus 7 by 10 whole square. 1 minus open 2 brackets 3 by 10 whole square plus 7 by 10 whole square. All right, got this? 0.42. Similarly, Gini of 5, 1 is equal to 1 minus open 2 brackets 5 divided by 6 close bracket to the power of 2 plus open bracket 1 divided by 6 close bracket to the power of 2 close bracket. 1 minus sigma probability square 0.2778. Now, Gini of variable A, it is weighted average, is equal to 0.42 into 10 divided by 16, 6 divided by 16. So 0.42 into 10 divided by 16 plus 0.2778 into 6 divided by 16, weighted average. So Gini of variable A is 0.3667. 0.42 into 10 divided by 16 plus 0.27778 into 6 divided by 16. Now, let us calculate Gini for one more variable, variable C. Gini for variable C. Now, these are the values for variable C. Now, let us say it has picked a value greater than equal to 4.2, less than 4.2. It randomly picked a value greater than equal to 4.2, less than 4.2. Now, within positive category, greater than equal to 4.2, within the negative category, 1, 2, 3, 4, 5, 6. 6 are there. Less than 4.2, all of them are less than 4.2, which is 8. And in this negative category, 2 are there, less than 4.2. So row total will be, the summation would be grand total. Gini of 0, 6 will be 0. If one of the value is 0, either in Gini calculations or entropy calculations, it will be 0. Even if you calculate, you will get it as you want, you can try also. Is equal to 1 minus open 2 brackets 0 divided by 6 to the power of 2 plus open bracket 6 divided by 6 to the power of 2 close bracket. So any one of it is 0. Gini of one thing which is 0 will be always Even if you calculate or not calculate, it will be 0. Gini of 8 comma 2 we have to calculate. Gini of 8.8 comma 2 we have to calculate is equal to 1 minus open 2 brackets 8 divided by 10 to the power of 2 plus open bracket 2 divided by 10 to the power of 2 close bracket. So we got 0.32. Gini of variable C is equal to 0 into 6 divided by 16 plus H16 10 divided by 16, 0.20. So what will be the first split? Variable C will be the first split. Now lowest Gini is variable C. It will split on variable C. Now copy the table. Just copy the table and paste it. We will calculate entropy. The tables won't change. The tables will remain same. Entropy and information gain for variable A. Copy paste the table. Entropy of 3, 7 is equal to minus open bracket 3 by 10 log open bracket 3 by 10 comma 2 open bracket 7 divided by 10 7 divided by 10 comma 2 close bracket. Let's say minus 1 into minus 1 into let's see, you check once. Minus 1 into. So entropy of 5 comma 1 here minus is equal to minus 1 into open 2 brackets 5 divided by 6 log open bracket 5 divided by 6 comma 2 close bracket plus open bracket 1 divided by 6 into log open bracket 1 divided by 6 comma 2 close 2 brackets. This is the formula for entropy 5 comma 1. Now weighted average. Entropy of variable A is equal to 0.88 into 10 divided by 16 plus M7 6 divided by 16. So entropy of equal classes is 1. Entropy of equal classes in dependent variable we have 8 positive and we have 8 negative, right? In dependent variable we have 8 positive and 8 negative. Entropy of equal classes is 1. If you calculate also you'll get 1. If one of the value is 0, it will be 0. Now, what is the formula for information gain? Information gain for variable A is equal to entropy of dependent variable minus entropy of information gain of variable A is equal to entropy of dependent variable minus entropy of variable A. Now you will get information gain of 0.20. So information gain is entropy of dependent variable minus entropy of, in dependent variable we have 8 positive and 8 negative. That means equal. Equal classes entropy is always equal to 1. If one of the value is 0, then it will be 0. Exactly you can calculate for, copy the table. So entropy of 0, 6 is no need of calculating, it is outrightly 0. Entropy of 8, 2 you have to calculate is equal to minus 1 into open 2 brackets 8 divided by 10 log open bracket 8 divided by 10 comma 2 close bracket open bracket 2 divided by 10 into log open bracket 2 divided by 10 comma 2 second base close 2 bracket with 0.72. This is the formula for calculating entropy 8, 2 for variable C. Now weighted average. Entropy of variable C is equal to 0 into 6 divided by 16 plus M16 into 10 divided by 16, 0.45. 0 into 6 divided by 16 plus 0.7219 into 10 divided by 16. Now calculate the information gain. 1 minus entropy of variable C. Information gain of variable C is equal to 1 entropy of dependent variable minus entropy of variable C, 0.54. So this is the process the algorithm follows to calculate for every independent variable with the classification. This is for classification. If you are using the classification model, then that one, this is for regression. So we are trying to predict hours played. Regression is numerical continuous variable, right? Hours played is what we are we are finding to predict. Standard deviation of hours played is equal to STD EV 9.67. Standard deviation of hours played is 67 is equal to STD EV is equal to STD EV, and select the column, you will get the standard deviation. Standard deviation of hours played. We will calculate the standard deviation reduction for Outlook variable. Now select the header, go to sort and filter, apply filter. Go to sort and filter, apply filter. Sort and filter and apply filter. Now we have three outlooks: overcast, sunny and rainy. Tick mark overcast. You'll get the data of overcast. So how many are there? 4 are there in overcast. Okay. And then let us do here STD EV of the overcast. 8.36. 4.30 you got, na? No. Paste the values separately. I think it is taking the data of other things also. First, this paste it like this. Calculate the standard deviation of overcast. Otherwise, it is doing wrongly. Copy the data into new location and calculate. This is the standard deviation. Count is 4. Count is 4. Now we will calculate for, so rainy, copy the data, Control C, paste it here, 5. Standard deviation is 12.51. Then unclick rainy, click on sunny. Copy the data, Control C, paste it here. Count is again 5 is equal to standard deviation is, how did you get 10.87? So standard deviation reduction is equal to 9.67 minus 8.59, 1.07. Weighted standard deviation. 5 by 14 plus 5 by 14 plus 4 by 14. Total observations is 14. 5 in sunny, 5 in rainy, 4 in standard deviation multiplied by 5 by 14. Standard deviation of rainy multiplied by 5 by 14. Standard deviation of overcast multiplied by 4 by 14. Charges means what? It's numeric, but it is showing as object. PD.2 underscore numeric, errors is equal to coerce. And then see if any missing value has come or not. There are no missing values, but the first problem you can see here is total charges is shown as object. It's a numeric data. Monthly charges and total charges should be numeric, right? So we need to convert total charges. So churn dir dot total charges is equal to PD dot 2 underscore numeric total charges, comma errors is equal to coerce. Then let us see if we got any errors. So 11 missing values have been imputed. 11 observations have been imputed with, 11 observations have been missing values are there. Now we have to impute those missing values. 11 is very small number, so you can do mean imputation or median imputation, your choice. Missing values, so we'll impute with mean. Churn dir dot total charges is equal to churn dir dot total charges dot fill NA. Churn dir dot total charges fill NA with mean. Now I'll run the info command again. Now we don't have any missing values and it is coming as float 64. So once you say coerce, errors is equal to coerce, it will, whichever data type it is not able to convert, it will replace it with NS. We got 11 NS. 11 is a very small number. So I have imputed with mean. I have replaced the 11 NS with mean. Now we don't have any missing value. Now the dependent variable is churn. Churn means customer leaving. So 5174 customers are still with the company. 1869 have left the company. Got it? Any doubts? Of course, Monday change. Busy on Monday change. All of you have imported the data. Why did I move senior student to object calls? Why did I move senior 0 means no? 1 means yes. So it has to be in object calls. So I moved it from numeric calls to object calls. Then I dropped it from, there are only 3 numeric calls. Tenure, monthly charges, total charges. Tenure, monthly charges and total charges are the only 3. Also drop customer ID. 7,000 unique. Next, what we will do? Okay, run this hypothesis test. Open your whole notebook and do it. Now, you want the hypothesis, the 2 chi-square tests. Done, chi-square test. Next is your, first you have to do group by. Yeah, you can find, because there is already a huge difference in mean. Variance will also be very different. Just copy paste the command, that's all. Huh? There is a large difference. 200 is the difference. Next one is total charges. Questions, only one is left, this one. Payment method and total charges. The last question is payment method and total charges. Third floor lo unnava reception lo ichesai. Reception lo ichama. ఇమాటికస్ లెర్నింగ్ అని ఉంటుంది, రిసెప్షన్లో ఇచ్చాయి. No, you can concat once the pre-processing is done, concat it, that's all. Keep it as separate data frame. We are using for hypothesis testing original data frame, which is not label encoded, because if you use label encoded data frame, you will not know what is what, right? So that is why I am using to complete the pre-processing concat. Now the data is ready for model building. So it is always better to concat and close the pre-processing. Now only thing you have to do is split it into Y and X and then build our model. Yes, you can also do that like that also. Your choice. Now I'll show you the process of building a model. You can try Y is equal to churn df underscore clean dot capital X is equal to churn df underscore clean dot drop single quote comma axis is equal to 1 from sklearn dot tree regressor or classifier. Tree is equal to decision tree classifier. Tree model is equal to tree dot fit x comma see 99 point sklearn dot model selection cross val score 3 comma x comma y cross validation. See how drastically the accuracy changed when I did cross validation of 5. Original is 99.74, but when I repeatedly tested the model with 5 subsets of the same data, look at the accuracy, it came down to 74%. This is what happens with overfitting. On trained model, you will get a 1 accuracy. When you repeatedly test it, your accuracy drastically changes. 0.20 is a very big change. Okay, 0.5, 0.05 here and there is okay. 5% change is okay. Or up to 10% is okay. But 20% change is a very, very big. So this is the problem of decision. Now what I can do, I can control it using max depth. So let us say I randomly take max depth of 10. See, it came down to 86. Now 86 and the 77, if you take the average, and p dot mean, and if I take the average of all these, see 75 and 86 are to some extent, 75 and 86 are to some extent, but if you still feel it is still high, reduce by 8 and then you take the array score. 78 and 83 is very close to 78 and 83 is average cross validation score is 78. Original model has 83. They are very close to one another. 5% is the, so you can use max depth to control the decision tree. So to control the decision tree, we need to use max. So the max depth will reduce the overfitting. So when you define the model, you can give the depth of the tree. And then when you do this is the process of cross validation. Cross validation. So if you look at the cross val score, sklearn. So basically we repeatedly test. Now you can go, by default is CV is equal to 5. See here. By default, if you don't specify any CV, it goes with 5. If you don't specify anything. If you don't specify CV is equal to none, we'll go with 5. See, 5-fold cross validation. None means it will by default do 5 times. Now there is one more thing called stratified k-fold. Subset and subset the data. Stratified sampling. Stratified sampling means layer-wise sampling. That's a different sampling method which is used. But here in CV, it uses random sampling. It randomly selects the rows, creates a subsample, and then puts the data into testing. So you can see here, the cross validation will test for the model fitness, whether how stable is your model. The model has to be, there should not be severe changes up and downs like this in the model performance. If it is like that, then it's a, so your model performance should be looking like a, see, if you look at this graph, see very high variance. This one. If you have underfitting means wrong classifications will be there. See, the circles are on the wrong side, and underfitting, misclassification will be there. In overfitting, you will have correct classification, but look at the curve. It is forcibly fitting, too good to be true. Whereas this is the appropriate fitting where you should have a stable, not that you should get every time you run the model exact value. There will be small changes, up and down will happen, but there should not be drastic changes. Drastic means very severe changes should not be. So underfitting and overfitting are important things. In the context of decision tree, they are very important. In the context of decision tree, so if you are looking at this one, this graph also will give you the proper model overfitting and underfitting. See, balanced model will have like this, slightly bented hockey stick style curve. Hockey stick style curve is your balanced data. If it is up and downs like this, see, underfitting will be a straight line. Wrong classifications will be there, misclassifications will be there. So you have to be very careful in classification, whether the model is overfitting or we have the same problem with regression. There R squares are plotted. R squares are plotted, class validated, and we'll get the values. Now, one other thing I have told you is variable importance. Variable or for the purpose of variable selection. PD dot data frame X dot columns, comma, tree model dot feature importances dot sort underscore values y is equal to 0 is equal to false. See, the most important variable is contract. The most important variable is contract, followed by tenure, monthly charges, online security and all. Least important variable starts from here. These are all 0 values. See, these are all non-significant. So you can take up to paperless billing. Some people say we will not take less than 10%. Then you have to go here only. From this onwards, all are insignificant. If you take internet service as the important, this is variable importance. Some people say I will take only about 10%. Below 10%, whatever it is, or closer to 1% or 0, we will take it as non-significant. So if you want to build a logistic regression model, if you build with this set of variables, you will get a better model than including all the variables. You can try later when you have time. So this is the important context of decision tree models. All tree models will give you random forest, gradient boosting. All of these are tree-based models only. They will also give you the variable importance, which are the important variables. Feature selection, reducing the variables for better model performance and selection. So you have to understand this sklearn dot tree export underscore graphviz tree model, comma, not export graphics, only. Plot underscore tree. Export graphics is the other one. Plot underscore tree. Very large model. Max depth is equal to 3. No, actually to see the graph, I am reducing it. Yes. So feature names is equal to. So the first split is happening on variable 15. You can double click on the plot and you can see it. The first split is happening on variable 15. So you can see here, the first split on happening on variable 15 less than equal to 0.5, Gini is 0.39 and 5174 on the left side, 1869, sorry, 3875 and 3168. 3875 and 3168, then 3875 split into 2631 and 1244. You can see the tree here. Max depth, how do we give the labels? If you want to see the text format, from sklearn dot tree export underscore text tree model. Feature names it is not taking. So you can see the text structure of the tree. If you want the detailed output also you'll get. Export graphics is there, na? Tree model will give you the text model of the tree. Diagraph tree you will get it. X15 label, the genies you can see here, right? List of string. I'll tell in the next class how to add these feature names. Then prediction. Tree predict is equal to tree model dot predict pd dot cross tab y comma tree predict. So you'll get the confusion matrix. So on this model, you try logistic regression at home. Logistic regression you can try, and also you can do the AUC curve and all what we have done in the previous. You can try on this models. So this is the theoretical background of decision tree for classification. So in the next session, we will do a regression example and then we'll go into the multi-tree models, which is random forest and gradient boosting. I told you now, close to less than 10%.